Hello, everybody. It's Wednesday, April 15th. Going to do section 7.6 to wrap up chapter 7. It is entitled Proportions. Proportions are really rational equations, but there are special types of rational equations. Basically, a proportion is when you have the equivalence between two fractions. So, in general, this is what proportions look like. Um, when you just have a single fraction on the left side of the equal sign and a single fraction on the right side of the equal sign. This is called a proportion. All proportions obey a interesting property, and this property says that when you have a valid proportion, you can always equate the cross products. So we can cross multiply, not cross cancel. Remember, you only cross cancel when you're multiplying fractions together. We've got the equal sign in between these fractions. But this property says that if I cross multiply, if I take this quantity here and multiply it by this quantity down here, so A times D, this property guarantees that that will always be equal to the other cross product, the product of this quantity and this quantity, B times C. So this is a very important fact that all proportions enjoy, or a property that all proportions enjoy. And it's this property that's going to enable us to solve proportions for a particular variable. Okay, so let's just dive right in. Let's look at solving a couple of proportions. Here's the first one. This is a proportion. Technically, it is a rational equation because we do have the equal sign and we do have rational expressions, but it's a special type of rational equation. One where we have a single fraction or rational expression equal to another single rational expression or fraction. Now, in the past, we showed you to solve rational equations, we get a least common denominator, build our fractions up to equivalent fractions, and then wipe away the denominators, and then solve the resultant equation. But ladies and gentlemen, since this is a special type of rational equation known as a proportion, all we have to do to solve this proportion for the variable x is to equate the cross products in using this property up here. So I can take x and multiply it by 8, and x times 8 is 8x. And I can set that equal to this cross product, 4 times 6. Hence, we have 8x is equal to 24, and now it's just a matter of solving this simple equation for x, divide both sides by 8, and therefore we walk out with a value of 3 for x, and we have solved this proportion successfully here. Alright, let's try another one here. You probably hear my grandfather clock going off in the background. It is midnight. My sleeping and awake patterns have been a little messed up because of this virus situation, but I'm making do. All right, ladies and gentlemen, we're going to try to solve this proportion for the variable a, and to do so, since it is a proportion, we can cross multiply and equate the cross product. So we take 3 times 5, and I set that equal to a plus 2 times a. I'm going to put the a in front of the factor a plus 2. And this is the equation that we're going to have to solve now. So again, when you have a valid proportion, it's legal to equate the cross products. This cross product can be set equal to this cross product. 3 times 5 is 15. We're going to have to distribute the a into the parentheses on the right side of our equation. So we have a squared plus 2a. And what we have here is we have a second degree equation to solve, and we learned in the past to solve these types of equations, we're going to have to get the equation set equal to 0. So to do that, we're going to have to drag this 15 over to the right side of our equation by subtracting 15 from both sides. So I subtract 15 from the left side of my equation, and I'm also going to have to minus off 15 from the right side of my equation. The 15s on the left side of the equation drop out to 0, and it leaves me with 0 equal to a squared plus 2a minus 15. I like to have my variables on the left side of my equation and 0 on the right side, so I am perfectly justified in just flipping this whole equation around, and I'll do that up here. So a squared plus 2a minus 15 equal to 0. And now this is the equation we have to solve, and ladies and gentlemen, the next step to solve this equation is to use our factoring method. So we're going to ask ourselves, can we factor the left side of this equation? Notice there's nothing we can factor out of all three terms. It is a trinomial. It's an easy type of trinomial, one with a leading coefficient of 1. We learned in the past that to factor these easy types of trinomials, all we need are two factors of the constant term that sum up to the middle coefficient. So I'm searching for a couple of factors of negative 15 that add up to positive 2. After a little thought, the only factors of negative 15 that work are going to be 5 and negative 3. These are factors of negative 15 that do indeed add up or sum up to give us positive 2, the middle coefficient. So the left side of this equation immediately factors into a plus 5 times a minus 3. A plus 5 times a minus 3. We now set both of these factors equal to 0, and then we just have two equations to solve. So there's one equation we're going to have to solve, and then we set the other variable factor equal to 0, and there's another equation we'll have to solve. Solving this equation for a, we subtract 5 from both sides, and we get one solution as being negative 5. Solving this equation for a, we add 3 to both sides, and we get a is equal to positive 3. Notice, ladies and gentlemen, back here at the original equation, we note that a restriction placed on the variable a is that a cannot be equal to negative 2. Because if a is negative 2, then the denominator of this fraction or rational expression becomes 0, and the whole equation is undefined. So one restriction placed on this equation is to say that a plus 2 can never be equal to 0. In other words, this denominator can never be 0. Which is then to say that a cannot be equal to negative 2. But notice our solutions do not violate our restriction, and therefore two solutions are negative 5 and 3. And we are done solving this rational equation or this proportion for a. I will solve another one. Want to solve this proportion for the variable x. You can list restrictions right now on this rational equation or this proportion. In order for this equation to be defined, the denominators can never be equal to 0. That's to say that x minus 2 can never be equal to 0, which is to say after you add 2 to both sides that x can never be equal to 2. Or that's saying that this denominator, x plus 2, can never be equal to 0 if our proportion is to be defined, which when you subtract 2 from both sides, this is saying x can never be equal to negative 2. So these are some restrictions here. Okay, to solve this proportion, ladies and gentlemen, we're going to cross multiply and equate the cross product. So I'm going to take 9 and multiply it by the quantity x plus 2. Make sure you enclose the x plus 2 inside parentheses. So we're going to take this cross product and we're going to set it equal to this cross product. 11 times x minus 2. Going to distribute the 9 inside the parentheses here and distribute the 11 inside the parentheses here. Hence, we'll have 9x plus 18 equal to 11x minus 22. 11 times negative 2 is minus 22. So this is the equation now that we have to solve. It's just a routine equation. We will subtract 11x from both sides. And then I will subtract 18 from both sides. By doing all this, we're going to separate the variable terms on the left side of the equation versus the constants on the right side of the equation. So 9x minus 11x is negative 2x. 18's are gone. 11x's are gone on the right side. And negative 22 minus 18 is going to be negative 40. Solving for x, we divide both sides by negative 2. And hence it looks like our solution x is going to be positive 20. And notice positive 20 does not violate any of our restrictions placed on the proportion from the get-go. And as a result, we would call this our solution. And that proportion has been solved. Okay, so I showed you how to solve some proportions. Proportions, ladies and gentlemen, are used to solve a lot of word or application problems. Everyone, I'm sure, at one point in time in our lives have used the proportional reasoning. It's done all the time. Just want to maybe look at a couple problems in our textbook here and see if I can, I don't know, maybe zoom in. This is page 497. Let me see if I can zoom in here. When I do zoom in, things tend to get a little bit fuzzy. Hold on a second here. All right, it is a little fuzzy, but this is on page 497 in your textbook. Problem 21 reads this way. On page 497, number 21. A baseball player gets 6 hits in the first 18 games of the season. If he continues hitting at the same rate, that's the key assumption here, how many hits will he get in the first 45 games? Well, to do this problem here, we can set up a proportion to answer this word question here. Okay. So let's see if we can do that. So this is problem 21 on page 497. Now again, it says that a baseball player gets 6 hits in the first 18 games of the season. So therefore, we can set up this proportion. 6 hits in the first 18 games. And then they want to know how many hits at this rate will the batter get in the first 45 games of the season. Now, this is very important when you're solving word problems using proportions. Your units have to be the same across. So if I have hits in the numerator here, I must have hits in the numerator over here. If I have games in our denominator over here, I would have to have games in my denominator over here. So in 45 games, how many hits would this batter get? Well, we don't know, so we give it a variable name here. And so therefore, ladies and gentlemen, this proportion is going to enable us to solve or find out how many hits this batter will attain in the first 45 games of the season, provided that their 6 hit per 18 game rate continues. Now all we have to do to answer this word problem is solve the proportion. So we cross multiply 6 times 45. And we're going to set this cross product equal to this cross product, 18 times x. Now 6 times 45 is going to be 270. Let me double check this. See, 30, 24, that looks like about right, and that's equal to 18x. Solve for x, we divide both sides by 18. And let's see, does 18 divide evenly into 270? Well, when in doubt, divide it out. So 18 divided into 270. x is equal to 15. And so therefore, ladies and gentlemen, we would expect the batter to get 15 hits in the first 45 games. And we're done solving that word problem. By the way, here's my division of 18 into 270. Sorry about that. I don't think you were able to see that. 18 divides into 270 15 times. All right, so that one's done. Let's look at another one here. This is, I'm going to hold this up here. Let's see, we'll be able to read this better here. This is number 25. This is on page 497, number 25. If 100 grams of ice cream contains 13 grams of fat, how much fat is in 350 grams of the same ice cream? We can set up a proportion to answer this word problem. So 100 grams of ice cream has 13 grams of fat. How much fat is in 350 grams of ice cream? Okay, so let's set up a proportion to answer this question. So again, this is problem number 25 on page 497. So it says if 100 grams of ice cream contains 13 grams of fat, so therefore I can say 100 grams, G for grams, of ice cream is to, let's see, 13 grams of fat. They want to know how many grams of fat we would expect in 350 grams of the same ice cream. Since we have grams of ice cream on top over here, we better have grams of ice cream on top over here. So 350 grams of ice cream. They want to know how much fat is in 350 grams of ice cream. We don't know what that is. We call it a variable or an unknown x. Ladies and gentlemen, we now have to just solve this proportion to answer this word problem. So we cross multiply 100 times x. I'm going to leave the units out for the sake of brevity here, the sake of simplicity. So 100 times x. And we set that cross product equal to 13 times 350. So therefore we have 100x is equal to 13 times 350 is 45.15. Therefore, to solve this equation out for x, we divide both sides by 100. When you divide a decimal by 100, the effect it has on the decimal point is to shift it 2 places to the left. So 1, 2. So therefore, x is going to be equal to 45.5. So there would be 45.5 grams of fat and 350 grams of ice cream. Okay. And we're done with solving that word problem by setting up a proportion. So again, this was problem number 25 on page 497. And so that's it, essentially, for section 7.6. Ladies, I'm not really too much going on with that section. We just showed you how to solve a proportion for an unknown and how to solve a couple of word problems by setting up proportions. Hopefully everything is going okay. We just have 2 more sections in this class, 8.1 and 8.2. I'm now going to close this video and work on the 8.1 video. So stay tuned and stay healthy.